Here are number 44 and 45 from section 2.2. We're given a piecewise function that we refer to on both questions. This piecewise function is 2x plus 1 for all x less than or equal to 0 and x squared plus 1 for all x greater than 0. These are multiple choice questions, but we're going to work them as if they were free response. Number 44 asks us for the left-hand derivative. That's what we're going to find here first. So we want the left-hand derivative. It's a limit. It's a limit as h approaches 0 from the left. It's of an f of our x value 0 plus h minus f of our x value 0 all over h. So now let's plug those into the function and see what we have. Limit as h approaches 0 from the left. I'm going to be using the rule 2x plus 1 because that's the rule that governs all the x values to the left of 0, and we're looking for a left-hand derivative. So plugging in 0 plus h is the same as plugging in h. So f of h in using 2x plus 1 as the function becomes 2h plus 1 minus our f of 0. If we plug in 0 to this function 2x plus 1, 2 times 0 is 0 plus 1 is 1. So we're left with just 1, and this is over h. You might notice now that the plus 1 minus 1 makes 0, and that leaves us with 2h over h, where the h's can cancel. So now we have a limit that is simplified all the way down to, as h approaches 0 from the left, of just 2. So the left-hand limit or left-hand derivative is 2, and that is answer choice B in number 44's multiple choice. 45 asks for the right-hand derivative. So this is also a limit. Limit as h approaches 0 now from the right. Still, it's going to be the same inside formula or quotient. So it's f of 0 plus h minus f of 0 all over h. The difference between 44 and 45 is with the right-hand derivative, we're going to use the function rule that governs all the x values to the right of 0. So x squared plus 1. So now as we expand this limit, f of 0 plus h is the same as f of h. So that becomes h squared plus 1 minus, and then f of 0, we're going to say 0 squared plus 1, that becomes just 1, and this is all over h. Well then, 1 minus 1, I'm going to use red here, 1 minus 1, that makes 0. And then h squared over h, we can cancel one of those h's. So this becomes h to the first over 1. And now this is a simplified limit of the limit as h approaches 0 from the right of just h. And h, a monomial, we can work by direct substitution. 0 goes in for h, and we have 0 for the right-hand derivative. And on 45, that's answer choice C.